Good afternoon, everybody, or whatever time of day it is, wherever you are. I'm Sharon Dooley. I'm going to be the moderator for this session today. We have an interesting topic from our sponsor, SUSE, supplies a Linux platform, and they're going to talk about high availability on that platform. Come on. We thank SUSE for their sponsorship of our group. Their money is what makes it possible for us to have raffles to give away after every session. It's the 20th birthday of PASS, happening on April 5th, and uh, there's information about it. There's going to be a party. There's going to be prizes and so forth. Big birthday party. At the beginning of April, we're also going to have 24 hours of PASS, showing the learnings and future vision. Registration is open for that. Do sign up. Somebody's coming. You can registration is open, and you save $150 if you use the code VGDISKG0E when you register. If you're interested in doing if you're a blogger and would like to become a PASS official summit blogger, you can apply before April 25th. We'll give you a discount to the event, and you'll get to access various interviews and so forth. If you've not been to a SQL Saturday, I urge you to find one. They're all over the place. I didn't edit this slide. I'm sorry a few of these have already happened since it's already the 27th of March. They're one-day free training events, and they are all over the world, and you can even have real good learning experience. Membership in PASS is free. Our Twitter, LinkedIn, etc. handles, or whatever you call them, you can tell I'm not a social media type, are there. And we are one of many virtual groups. There are some that are specific to various areas like performance and like this one, database administration. There are some that are language specific and some that are sort of mixed things. And one of the ones I'm most interested in is women in technology. It's a wonderful opportunity to learn from some of the extraordinary women who are members of PASS. And every year at the summit, we have a good speaker talking about her life as a woman in technology. And now I'd like to turn the meeting over to our presenters, Surab and Balaji. Surab is a senior program manager for the Microsoft Data Platform Group, and he is the owner of the high availability disaster recovery components of the SQL Server release. He's been at Microsoft for over a decade and has worked on different capacities and specializes in providing consulting services on SQL Server and other data platform technologies. Balaji Barmavat is a public solutions architect at SUSE. He has more than 14 years of IT experience, and with 7 years focused on business application solution architecture, applications cloud migration, applications modernization, data and open source solutions. Balaji focuses on technical innovation and product solutions on public clouds. And now I'm going to make them the presenter so that they can do their thing, and I will, at the end of the session, I'll pass your questions on to them.
Thank you, Sharon. Let me know if you can see my screen.
I can see your screen.
Perfect. Thank you. Let's go ahead. I'll let Balaji talk about SUSE in the beginning and how to set up a SUSE HA cluster, and then we'll get on with the specifics around SQL Server and how do you configure HA for SQL Server on a SUSE platform.
Solid. Yeah, thanks, Saurabh. Okay. Hi everyone. Good morning and good afternoon. Today's agenda is we will focus on foundation on clusters, cluster concepts. We'll talk about cluster components, cluster terminology, and we'll talk about SUSE HA setup. So the HA is the short form I'm going to use for high availability. And we'll talk a little bit about HA product overview, and Saurabh has a cool demos he built on our HA with SQL Server. So he's going to show you how you can create a AZ and some of the failover steps. All right, so before we start for HA, okay, so yeah, so first talk about the challenge first. Challenge in enterprise. So the biggest challenge is the business continuity. So the business continuity depends on the underlying applications they are going to run for the business. So apparently, they are the applications which has the data as a backbone. So if the data is not available, the application is not going to run. As a result, the business continuity. So there is an issue in business continuity. So the data is an asset right now in most of the organizations. I can say all the organizations. So the making data is available for the application is the key. So challenges. So if you think about the Murphy law, it says anything that can go wrong will go wrong. So we have two types of failures will occur. One is the planned downtimes where we want to have server maintenance and all, but there are unplanned maintenance like hardware crash, floods, fire, outage, and so on. Right? So when unplanned downtime happens and it results in service outage or the loss of data, so how much a customer can afford low availability? So the ultimate question here is around high availability, how much does the downtime cost or how much can a customer afford to lose? So before moving on to the HA, whether really we need HA or not, so let's talk about what all are the factors for HA. So right, so apart from cost, the main decision for HA or not HA depends on large number of factors regarding the application which is accessing the data. For example, if a application is a customer front-end application, like you can think about Uber or banking application, or any application which is customer front-end, and it is accessing the data, we should make sure the data is available 24/7. Let's say the customer, let's say there are few applications which are not customer facing and they are using within the organization, and based on the organization needs, it can afford to lose some time. It can be down for some time. So let's take an example where, let's say, it's a mission critical data and the customer applications are accessing that. So whenever unplanned downtime happens, so rebooting is not at all the option instead of doing a failover, or instead of having a HA in place, right? Or redeploying instead of a failover, right? So rebooting and redeploying not at all options if your data is very critical for apps, right? So yeah, think about an example where, let's say, something happens morning 4 a.m. right? We can't bother DBAs or support team. Server is down, there is a sudden power outage, right? So we need to handle, or we need to prepare, handle all those things. So we will now move on to the cluster concepts. So the cluster is basically a collection of 2 or more nodes connected. And why we connect these 2 or more nodes is to make sure that service is available regardless of software, hardware failures. And here we are not trying to avoid the failures. Instead, we deal with failures. Failures are a fact. It will happen. Not today, maybe in future, right? So we need to prepare to handle those failures. So the basically clusters are 3 types. So one is the basic cluster. Basic cluster has 2 nodes. They are connected each other. And next one is the metro cluster. The metro cluster is basically same as a basic cluster, but they are within 30 kilometers range. Nodes are connected within 30 kilometers range. And limit here is the latency. So it can afford 5 milliseconds of the latency. And third type of the cluster is geocluster. Geoclusters are clusters of clusters that may span the entire globe. So in geocluster, we have a long latencies because they're spanning entire the globe. For SQL Server, so Saurabh is going to talk about which cluster we are going to use. And the way we advocate all the enterprises is, though HA is a product, we communicate them it's a process. So what I mean is, we have a product, we set up and we go, and fine, it works. But over the time in the database world, the data grows, right? As a result of business growth. So we need to monitor the changes in databases case. We need to monitor what is the response time, what is the disk usage, CPU time, right? So the point I want to put forward is, it is a process you are going to monitor and manage day by day, right? Because it's something you have to maintain and you have to keep an eye on it. You have to aware how it works and what are the limitations, especially as your business changes, right? And I'm sure, so it's never a completed, finished thing. So we need to touch our hands on knowing the process, how it works, and what all are the areas, and so on and so forth, right? And again, it's not technically it's a product, but we need to make it a process. Okay, the main purpose of HA is to making sure that we have a continuous operations as much as possible. And we also make sure that the core requirement of HA is to making sure that data integrity, right? So having applications highly available is no good if the database is lost on failure. So our HA comes with several tools for ensuring the data integrity. For example, we have a fencing mechanism, which provides a layer of defense against the data loss or corruption. So we'll talk about when we are going to talk components. And the key to HA is to handle single point of failures, or to eliminate any single point of failures. This includes your hardware, your software, your network infrastructure, so on. So consider all the things when you are thinking about possible cause of outages, right? So let's say database can go wrong because of network interfaces or power outages, right? So the goal is to handle, to prepare to handle all single point of failures. And at the same time, let's say if any failures happens, and goal is to minimize the mean time to recover after a failure. What it means is as quickly as possible to recover database, right? So no matter how much care is taken reducing the time between the failures still occur. The key then is to react and recover from the failures as quickly as possible, right? So we might create procedures to recover as quickly as possible, or scripts. So we have a package or product called HA, high availability. So now we'll talk about the overview of our HA. So our HA product available over 15 years. And SUSE Linux Enterprise High Availability Extension is an integrated suite of open source clustering technology that enables HA on your physical or VMs, so that you can implement HA for your databases. It has so it helps to maintain the business continuity, and it has various procedures and methods to protect the data integrity, so that we can reduce the unplanned downtime for mission critical workloads. And it has various wonderful features. So I want to call out few features which are relevant for DBAs or databases. So our HA product fully supports for major hardware platforms, x86, Power, System-J. So it works. It works in on-prem, it works in bare metal, and it works in cloud. It's a virtualization agnostic. And our HA product has a core component called Pacemaker. Pacemaker is a cluster resource manager. We are going to talk about that. And another key thing is our product has a web UI GUI. It's called Hawk2. So we are going to demo that. So so our product gives the ability, you can view the cluster components, cluster resources, and we can see what's happening in the cluster. So we have a base Linux Enterprise OS, and in the previous webinar we had demoed you how we can install or set up SQL Server on our SUSE. It's a base one, and if you want to configure HA, then you need to extend or you need to have HA package or HA extension. It's an additional package you with a single command you will just install. And installation is very straightforward, easy. So you just first install all the patterns for HA, all the packages for HA. Then for node 1 or main node, so you just do the init. Then other nodes, ask the other nodes to join the cluster. So basically you run HA cluster init on the one node, which is the primary node, and remaining nodes ask the nodes to join node 1 in the cluster, right? It's very easy to set up. And once the setup is done, you can see the status by GUI, or we have a command called CRM, Cluster Resource Manager. So you can see the status. And Saurabh is going to talk about briefly when it comes to the HA for SQL. So when it comes to the HA, so we need to learn certain terminologies, right? Because it has its own terminologies, because you'll be using these terminologies day to day when we are working on HA. The first thing is a node. Okay, the node is simply a computer or a server in the cluster, right? So for SQL, we have 3-node cluster, means 3 servers, three VMs, right? So it's a node. And the next one is a resource. The resource is any type of service or a script or application that is known to the pacemaker. Okay. In other words, the resource is a script or a service which is configured in the cluster, and cluster can manage it. Right. For example, when it comes to the SQL, so Saurabh is going to talk about AZ, right? And is going to talk about a couple of resources he's going to configure. Then resource groups are resource sets. Okay, the cluster resources are held together in a cluster within cluster groups. The basically a set of resources are grouped as resource groups or resource sets. And the next one is constraints. The constraints are we need to determine the behavior of the resource in a cluster with help of the constraints. Basically, you control the resource by imposing the constraints. And third one, and the next one is very important one, is fencing. So we are dealing with nodes in the cluster. If a node has unresponsive behavior for some reason, right, we need to isolate that. We need to isolate that node. So we need to fence it. So we have a fencing mechanism in the HA in our package, so you can easily fence it. The last one is quorum. The quorum is quorum for a cluster is determined by the number of voting elements that must be part of active cluster membership. Basically the how many votes we need to have to make the cluster to make active cluster. The number of nodes. The basically quorum. Now moving on to the components. So we have the cluster is a twofold process. Our cluster has a twofold components, or two types of the components. One is one part is at pacemaker level. Next part is on the SQL side. And so I'm going to cover at pacemaker level. So as I said, we have a pacemaker is a CRM, cluster resource manager, and it is the responsible of managing or controlling nodes within the cluster, and it's also responsible to manage the resource which are in the cluster, right? And the way we configure and so we have a default package, and as I said, you can configure the nodes. So once the nodes are configured, we have something called corosync or corosync configuration. So the corosync is the messaging mechanism within the cluster to communicate the nodes. In other words, since we are going to talk different nodes, we need to have an internal mechanism to making sure that node is alive or active. The corosync is the corosync component handles the messaging of the nodes or communication of the nodes within the cluster. And you can see that file, configuration file corosync.conf when you install the cluster or when you configure the cluster. And if anything happens in the message, if anything happens in the communication, so that will be logged in the corosync log. So that is very important. If your corosync configuration is not configured properly, or it has any syntax mistakes or anything, then you will have issue in cluster. So this configuration is very important to check. So once we have defined which are the nodes in my cluster, the second thing is we need to decide for fence method. The fencing is, the idea of fencing is if a node is unresponsive for some reasons, right, we need to take the node out of the cluster so that it will not corrupt the data, and thereby we can achieve data integrity. So we have various fencing methods. And the next one is libqb. It's basically a library for the logging. So if you want to have a detailed logging, so we have a logging library, you can just include that, and you can get lots of logging. Then SQL Server HA resource agent.
Sure. Thanks, Balaji. I'll talk about the SQL Server resource agent and the external cluster type. But before we get into the discussion around SQL Server HA resource agent and the external cluster type, I wanted to quickly talk about the HA capabilities which SQL Server introduces and the specific technology or the feature which we will talk about in the next 20-25 odd minutes. Right? So in SQL or in SQL Server, we have two key HA technologies or features which customers can use for their HA requirements. One is what we call as failover cluster instances, and the second is SQL Server availability groups. So failover cluster instances are a typical shared storage HA mechanism where in a 3-node cluster or in a 2-node cluster, you have a shared disk, which is where we host the SQL Server files. And if the shared storage goes down, your entire SQL Server is unavailable. And if one of the nodes hosting the shared storage goes down, cluster can move the shared storage to the next node, and SQL can come back online. Availability groups are different from shared storage in the sense that we don't use a common, or we don't use a single point of failure in an availability groups. Each node within the cluster has its own storage for the databases and the log files associated with SQL Server. Now, internally, SQL Server uses a replication or data replication mechanism, which ships the logs from the primary replica or the primary server where read-write connections are happening, or or users are connecting to perform read-write operations, to one or more secondary replicas within the cluster. With always-on availability groups, we support up to 9 replicas, which is 1 primary plus up to 8 secondary replicas. Out of these 8 secondary replicas, you can have up to 4 sync secondary replicas, and additional 4 can be an async secondary replica. This increase in the sync secondary replicas is a feature which we are introducing in SQL Server 2019. If you talk about, or if you are working with SQL Server 2017, we support up to 2 sync secondary replicas, and rest all can be async secondary replicas. Right now, in order to get availability groups to work with Pacemaker on SUSE Linux or any other Linux distribution, we created what we call as the SQL Server HA resource agent. So this resource agent is responsible for doing the health check and resource monitoring on SQL Server to determine if the availability group hosted on that replica or on that node is alive or not. And if that replica or the availability group on that replica is not alive or it has some problems, it will signal to the Pacemaker cluster to fail over the resource to 1 or more sync secondary replicas. The external cluster type is a concept we introduced for SQL Server to work alongside Linux distributions and Pacemaker clusters. So SQL Server traditionally has been a Windows application, or a Windows was supported traditionally with Windows servers, and with Windows Server failover clustering solution, SQL Server it tied very well together with the Windows failover clustering solution. I'll talk about that in a bit more in the next section. But essentially, the fact that Pacemaker and Windows failover clustering solutions, they work a bit differently. We had to introduce a new clustering mechanism which allows us to interact with Pacemaker differently from what we do with Windows failover clustering. So the specifics of how Pacemaker interacts with, SQL Server interacts with Pacemaker vis-a-vis how SQL Server interacts with Windows failover cluster is what is defined on this particular slide. In Pacemaker, Balaji talked about the CoroSync capability and the Pacemaker cluster itself, right? And on top of the cluster, you have your SQL Server instances. Each SQL Server instance has its own resource agent associated with it, which does the health check and the resource monitoring, right? When, excuse me, when a resource agent determines that the primary replica for that availability group is not available or it has some problem, it will signal to the CoroSync or the Pacemaker cluster to do a failover to one of the existing sync replicas. In case of WSFC, that is Windows Server Failover Clustering, this architecture is a bit more tightly coupled in the sense that we do not use a separate resource agent for each of the underlying nodes or SQL servers in the WSFC. We have a single resource DLL which interacts with the WSFC cluster to perform failovers and resource health check and everything else, right? So to simplify this, WSFC is a bit more tightly coupled with SQL Server, while Pacemaker and SQL Server is a bit loosely coupled in the sense that if you take certain actions in SQL Server, it does not automatically reflect back in the Pacemaker. For example, if you create a resource or an AG resource in SQL Server, it will not automatically go and get created in the Pacemaker cluster. There are additional actions which needs to be performed for these resources to be available in Pacemaker cluster. I'll talk about these actions in a bit. In WSFC case, whatever you do on the SQL Server automatically gets reflected on the WSFC cluster. So if you create an availability group in SQL Server, it will automatically get reflected in WSFC as a resource. So no additional actions are required on, from the DBA's perspective or from a Windows admin perspective to have those resources available on WSFC. When we talk about HA on Linux and specifically about availability groups, we also introduced a concept called required synchronized secondaries to commit, which is essentially a data protection mechanism wherein essentially what this means is that if you set this value to 1 or 2, right, you will need at least one sync secondary replica to be available for your read and write operations to be successful on the primary replica. If, let's say, for a reason your secondary replica is not available, we stop accepting connections on the on the primary replica. So as I was saying, this is essentially a data protection mechanism where we don't want to commit transactions on a replica unless there is a corresponding sync replica also available. The default values for read synchronized or required synchronized secondaries to commit is 0 for a WSFC cluster, and for Linux clusters it varies depending on whether you are running a 2 sync replica setup or a 3 sync replica setup. In case of a 3 sync replica setup, the value is set to 1 by default. In case of a 2 sync replica setup, the value is set to 0 by default. Right? So in case of a 2 sync replica setup, if let's say your secondary replica is out and the default value of 0 is set for required synchronized copies to commit, your primary replica would continue to function as is without any intervention, without any issues on the client application. But if you set this value to 1 and your secondary replica is not available, primary replica won't be able to accept user connections. Right, so that's a lot of talking. So let's go and see a quick demo on how do we set up an availability group in SQL Server, and then we'll talk about how to create the corresponding Linux Pacemaker resources for the availability group. So I'll switch the control to my SQL Server Management Studio. Now, for the purpose of this demo and to make sure that we don't end up spending a lot of time in configuring the cluster, I have already set up the HA cluster, the Pacemaker cluster for SQL Server. And on this Pacemaker cluster, I have 3 SQL replicas or 3 SQL nodes running. I have done a bit of the pre-work in terms of creating the certificates and logins for each of the SQL Server nodes to talk to each other. And I have also set up the endpoints through which SQL Server replicas communicate with each other. Right. In my case, I am using a certificate for endpoint communication and authorization and authentication, which the certificate definition is defined over here. We'll make this, and this code is available on the Microsoft documentation site. I'll share. We'll figure out a way to share this slide or the demo script post the session. Right. So going back to my availability group setup scenario or the demo. So the key to setting up the availability group is a couple of things here. The first thing is defining my cluster type as external to indicate that this is a Linux cluster on which we are installing or creating availability groups. Right. The other important things are obviously the AG name, the availability group name, and whether and what are the replicas this availability group would be created on. So in my case, I have 3 Linux SQL Server on Linux deployments. The SQL Server names are Node 1, Node 2, and Node 3. And the endpoint on which they will communicate with each other is on port 5022. Right. So this is pretty straightforward. This is a regular T-SQL availability group create statement, which has been there in the product since SQL 2012 days. Right? That's about 8 years. It's been 8 years since we have had availability groups into the product. So as part of my demo, what I'll do is I'll connect to my one of the SQL Server instances and use create a database on that instance and add that database to my availability group. So let me go ahead and quickly run this command. Sorry, I need to enable this. Okay, that's fine. Right, so I executed my script to create an availability group. Oops, sorry, my bad. But that should have still created the, okay, yeah, that's fine. So I did create my availability group. That I got an initial error because I had selected this line at the top and it did not, I mean, it was not defined as a correct commented outline. But then anyways, right, so once my availability group is created, I still need to go to my secondary replicas to join to that availability group. So before I go and do that, let me quickly go back to my primary replica and show the availability group which is created. So if you notice now, I have a new availability group called AG2, which has been created on my server 13.67. I mean, the IP address is 13.67, so on and so forth. I will go to my secondary replicas and run the command to join to that availability group. I am also providing the permission to this availability group to create databases as a replica of the primary availability group. So in this scenario, when I was doing my AG setup, I added a database to my availability group, the test DB2. Now this database will automatically get created on the secondary replicas if I provide this command, this permission to create the database. And in my availability group, I had selected the seeding mode equals to automatic, which essentially means that SQL Server will automatically take a backup of your database, a VDI backup of your database, and restore it on the secondary replicas. So let me go ahead and run this command so that all of these, my availability group is created on the secondary replicas, and the database is also created. So once this completes, I'll connect to one of the secondary replicas and I'll show you the database available on those secondary replicas, and that the database is synchronized. So if I go back to this secondary replica and try and expand my databases, it's still not available yet. This query is still executing. So as soon as this query executes and completes, I should be able to see my availability group database on that replica. So in my example, I had the 52 server first. So let's go and see if my 52 server has the, so the AG2 was created on the 52 server, and my database was also created on the 52 server. And now that I see that my commands have completed, I should be able to see the database on the node 3 server also, right? So right now this availability group is only present on SQL Server. It does not have a corresponding resource on the Pacemaker cluster. So let me show you the state of my current Pacemaker cluster. So I can use the command CRM Status to show to see what are the resources running on the Pacemaker cluster, and what, who is the master node and what are the slave nodes for these resources. I could also run a command called CRM config show to give a detailed output of the properties associated with each of the resources and the properties of the HA cluster itself, right? So in this case, you can see that I already have a pre-existing availability group resource for my AG1, and these are some of the properties associated with that resource, right? I'll talk about some of these properties, start, stop, promote, action, and all that in a bit, right? So let's do this. Let's go ahead and create a new resource for my availability group, which I just created. And I have this command here already. So essentially, I'm creating a primitive resource on my CRM or the Pacemaker cluster with the name AG cluster 2. It is of type MS SQL AG, and it corresponds to my AG2, which I just created, right? And it has the same property settings for the start timeout, stop timeout, promote and demote action timeouts. Now, by default, these values are 60 seconds. For the sake of this demo, I have changed these values to 30 seconds to ensure that my agents don't, or my HA agents don't spend a lot of time in waiting for the timeout for these actions. So let me go ahead and run this command. I'll copy this. So before I copy this command, let me just run this. So I committed my Pacemaker cluster resource to the cluster, and I will exit from my config session. Sorry, let me just hide this guy. Yeah. So let me commit everything before I exit. Okay. So now if I go and do my CRM status output, you'd notice that I have a new resource created over here for AG cluster 2, and that resource is currently in the phase, my monitoring has started for that resource, where node 3 is my master for the resource, and node 1 and 2 are the slaves for that resource. If I go and run my previous command, which I was running the sudo CRM config show command, I would notice that there is a new primitive resource type with the values of, with the name AG cluster 2 and with the types MS SQL AG created on my cluster. Right, so let me clear this, sorry, and do a quick CRM status. So if you notice over here, the resource is now fully up and running with master node as node 3 and the slave nodes as node 1 and node 2. Right, now I'll show you a failover sequence for this resource in a bit. But before we get to that, let's just quickly talk about a few things associated with the HA agent. Right. So as I said in the beginning, that the HA agent is responsible for all monitoring and health check for the AG resource on the cluster, and if it identifies a problem with the primary replica, it will signal to the Pacemaker cluster to do a failover of that resource. So in SQL Server, we use a sequence number method, or a method based on the sequence number, to determine if a particular sync secondary replica is a good target for failover or not. So essentially, every time we commit a transaction on the primary, and that transaction is, every time we do a transaction on the primary and we send that transaction to the secondary replica, and that transaction is hardened on that secondary replica, we update the sequence numbers to indicate that the primary and the secondary replicas are in sync. And as part of the failover logic, we determine which sync replica has the most up-to-date sequence number, and we pick up that replica as the failover target for the availability group resource. So that's the automatic failover capability for availability groups. Right. Now in SQL Server, we use a predefined stored procedure called SQL Server Diagnostics to check for whether the resources are alive or not, or if the resources have any problems. So in case of SQL Server availability groups, the SQL Server Diagnostic returns various, depending on the failure type, it will return various failover condition levels or failover target levels. And the default value of 3 is what we use for SQL Server availability groups. If for some reason SQL Server or the agent receives a failover value of 3 or more, or it's not able to connect to the SQL Server at all to determine the health, it will initiate a failover request to the Pacemaker cluster. And these are very similar to what we do in WSFC failover. Right. So I talked about the failover sequence, or the failover part of it. So what are the sequence, or what are the operations which we do as part of the failover? Right. So as part of the failover, and this is not typical to SQL Server. This is a strategy which is used for every resource on a Pacemaker cluster, right? So essentially, you demote the resource on the current primary or the current master node, right? You then try to promote the resource on a new secondary replica, or the new targeted primary replica. As part of this demote and promote actions, you stop the resource on the existing primary replica and start the resource on the new primary replica. And there are a sequence of steps which also gets, along with the promote and demote and start and stop. Essentially, we do some pre-start, pre-promote, pre-stop actions to ensure that my resource has moved over successfully to the HA, or one of the available secondary replicas. Right. Let me show you a quick sequence of these steps as part of the failover itself, right? So for this failover, I'm going to use a command, and this is very straightforward, right? I'm using a command called resource move. I'm going to pick up the first cluster or the first AG resource which I had and move that resource from node 1 to node 2, right? So this has created a new constraint, but that's fine. I mean, that's a Pacemaker property that it creates a new constraint every time you do a manual failover. And a good recommendation or a best practice recommendation from SQL Server is that you should always delete this location constraint after the failover has been completed. So in this case, you can notice that right now my cluster is trying to promote node 2 as the primary replica for the availability group resource, and it has already demoted node 1 as the primary from the primary replica, and it's now a slave replica. So it is currently giving me an error message that, or the action message that the failover cluster or the monitor action is not running, but that should go away in a few seconds, right? So while that is happening, and you notice that my node 2 has become master already, if I go back to my SQL Server and connect to my node 2 instance, you would notice that AG1 is now primary on node 2 instance. And earlier it was primary on node 1. If I refresh this, you will notice that this has become secondary on the node 2. So that's how you do a manual failover within SQL Server. And as I was saying earlier, if you look at the full config output, you would notice that a new location constraint has been created on the Pacemaker cluster. And as I was saying, a good practice is to remove this location constraint so that Pacemaker does not try to always bring the resource online on node 2. So essentially what this location constraint means is that my resource should always be preferred to run on node 2. And this can lead to unwanted failovers in certain scenarios, right? So while we were talking about we talked about the UI, or sorry, Balaji initially talked about the UI component for Pacemaker cluster called Hawk2. Let me quickly show you the Hawk2 cluster or the Hawk2 UI for Pacemaker cluster on SUSE. So this is the dashboard for the Hawk2 cluster, where I can see the status of my resources on that cluster, and I see that my resource, the AG cluster resource, is running online on node 2, while node 1 and node 2 are slaves, and for AG cluster 2 resource, node 3 is primary, while node 1 and node 2 are slave nodes. I can also go and check the node status for my replicas as to what are the nodes and what is the current status of these nodes on the failover cluster, right? And if I need to add resources or constraints to my Pacemaker cluster, that can be done through the UI also. I can choose to create a primitive resource. I can choose to create a group. I can create a template, a tag, different types of resources on the cluster. I can choose to do the same thing for constraints. So essentially, you have a UI way or a UI to help you create these resources without having to, remember these bash commands for creating the resources, right? So finally, as part of the of this webinar, I've listed out a few key commands which are useful for managing a SQL Server availability group resource on Pacemaker on SUSE. Some of these commands are native to, obviously, sorry, my bad. All of these commands are native to CRM, the Cluster Resource Manager, with a few tweaks to ensure that you can create an availability group resource and the properties associated with that resource. When we share the slide deck, I will add a couple more commands to this. Essentially, the commands around how to move a resource, how to create the resource for availability groups, and so on and so forth. So that's pretty much what we wanted to cover as part of this session. I'll pass it over to Balaji to talk about some call to actions.
Okay. Yeah, thanks, Saurabh. So right now we are offering customers for 100% discounts on SUSE Linux Enterprise Server 12 SP3. It's a SQL on Linux bits, so you can use that offer. And on top of it, Microsoft also offering 30% discount on SQL Server licenses. And this offer only applies for BYOS. And SUSECon is one of our biggest technical conference. And if you happen to be in Nashville, so we would request you to attend our conference. You have access to so many technical trainings, experts, a whole lot of information. And Microsoft is a cornerstone sponsor for this event. And some of the Microsoft SQL engineering team members are going to talk about SQL and containers and other stuff. And if you are not able to make it, you can sign up and we will mail you the recordings and information. So that's all we have for the day. Thank you so much. And if you have any questions.
Yeah, we should be able to take the questions.
Yeah, I have a few questions. One of the questions is, how similar is rack in Linux to Pacemaker in SUSE?
When you say, I'm assuming the question pertains to Oracle rack on a Linux server vis-a-vis Pacemaker cluster on SUSE.
That I can't tell.
I think, yeah. So if the question is with respect to Oracle rack is essentially a clustering technology from Oracle, which allows you to do a multi-master, access of their Oracle instances. So essentially, you have two Oracle instances which are configured in a rack instance or in a rack configuration, allowing you to connect to each of these two instances and run queries. The corresponding capability in SUSE, I mean, it's not necessarily a SUSE capability. The corresponding capability would be SQL Server availability groups. When you compare Pacemaker on SUSE, you would probably want to compare that with Cluster Aware on an Oracle Linux. I can follow up on that question again if Sharon has my email address, so please feel free to send that question to us, and I'll follow up on that again. And we can go into the more details on that.
Would you know if there are companies running SQL Server HA Linux in production? I have tried to set up HA and Linux on CentOS and found that we have node failover that happened without reason.
So CentOS is not currently a supported distro for SQL Server. But to the first part of the question, yes, we have a lot of customers running SQL Server on Linux in production with HA capabilities or with HA configurations.
Okay, that seems to be all the questions we have at the moment. If you could send your PowerPoint and your demo scripts to me, and I will make sure that they get posted.
Yep, we'll do that. Sure. Thank you.
Okay, we'll post them along with the recording of the session. So I thank you both for this interesting session. I think most of our attendees seem to have enjoyed it and learned a lot about working with SUSE Linux. And I'm going to end the session now, and everybody can go have lunch or whatever their next option is. And thank you all for coming, and we'll see you another time. Thank you.
Thank you.
Thank you.
Bye-bye.
Bye. So